The immunological structure of the skin. In this section, skin immunity under pathological conditions will be discussed. The skin immune system under pathologic conditions. Under pathological conditions, the skin immune system can be activated by several different stimuli. These include microbial invasion, such as bacteria, viruses, and fungi, irritants, drugs, or sensitizing haptens that trigger allergic reactions, and environmental or physical stressors, including ultraviolet radiation, trauma, heat, and cold. Regardless of the trigger, the major clinical outcome of immune activation is tissue inflammation. The first response is the innate immune response, which provides rapid, nonspecific defense against harmful stimuli. This response involves several key immune cells, including granulocytes, such as neutrophils, eosinophils, and basophils, which rapidly attack invading pathogens. Monocytes migrate into inflamed tissue and differentiate into macrophages or dendritic cells. Natural killer NK cells eliminate infected or stressed cells, while innate lymphoid cells (ILCs) produce cytokines that shape the local immune response. Another important cell type is the plasmacytoid dendritic cell (PDC), which secretes type I interferons to coordinate antiviral immunity. These cells often accumulate at the margins of active skin lesions, helping contain infection while amplifying inflammatory signaling. Together, these innate immune cells bridge the innate and adaptive immune responses. Innate-driven skin diseases. Several inflammatory skin diseases are predominantly driven by innate immunity. These include pustular psoriasis, pyoderma gangrenosum, and acute generalized exanthematous pustulosis, AGEP. Other examples include acne inversa, rosacea, autoinflammatory syndromes, eosinophilic fasciitis, and eosinophilic cellulitis. Adaptive immune response and associated diseases. The adaptive immune response is mediated primarily by different subsets of T helper cells, each associated with distinct skin diseases. Th1-mediated diseases include lichen planus and tuberculoid leprosy. Th2-mediated diseases include atopic dermatitis and acute graft-versus-host disease. Th17 responses play a major role in psoriasis and acne vulgaris. Allergic contact dermatitis involves both Th1 and Th17 responses. Cytotoxic T cells are thought to contribute to chronic lichenoid graft-versus-host disease and toxic epidermal necrolysis. Th9 cells have also been identified and are increasingly recognized for their potential role in anti-tumor immunity. Memory T cells and skin disease. Recurrence of many inflammatory skin diseases is largely driven by tissue-resident memory T cells, TRM cells, which remain in the skin long after the initial inflammation has resolved. Antigen-presenting cells, APCs, play a crucial role in maintaining these T cell responses. For example, TIP-DCs and SLAN dendritic cells produce IL-23, which supports the survival and activation of Th17 cells, a key pathway in psoriasis. In contrast, myeloid dendritic cells promote Th2 cell expansion, contributing to the development of atopic dermatitis. Understanding these immune pathways has important therapeutic implications. Targeting APCs or the cytokines they produce can effectively reduce disease activity. For instance, guselkumab, an anti-IL-23 monoclonal antibody, is highly effective in treating psoriasis by interrupting the IL-23 Th17 signaling pathway. Skin cancer and immune contexture. The skin immune system also plays an important role in tumor immunity. It contributes to the immune-mediated regression of skin cancers such as melanoma and precancerous lesions like actinic keratosis. As tumors progress, however, the tumor microenvironment often becomes increasingly immunosuppressive, allowing cancer cells to evade immune surveillance. Several immune features are associated with prognosis. Poor prognosis is linked to increased infiltration of granulocytes, plasmacytoid dendritic cells, and M2 macrophages, as well as elevated levels of immunosuppressive cytokines including IL-4, IL-10, IL-13, and TGF-beta. Conversely, better clinical outcomes are associated with abundant infiltration of CD3 T cells, CD8 cytotoxic T cells, and CD4-5RO memory T cells within the tumor. An emerging area of research focuses on Th9 cells, which may enhance anti-tumor immunity and represent a promising target for future cancer immunotherapy. Summary: In summary, skin inflammation results from a complex interaction between the innate and adaptive immune systems, involving keratinocytes, dendritic cells, natural killer cells, and multiple T-cell subsets. Different T helper cell populations define distinct disease phenotypes. For example, Th17 cells are the major drivers of psoriasis, whereas Th2 cells play a central role in atopic dermatitis. These immune pathways also provide important therapeutic targets. Antigen-presenting cells and cytokines regulate both disease progression and recurrence, making them valuable targets for biologic therapies.